Hi guys, my name is Carlos and in this video I want to share how to apply artificial intelligence for remote sensing data processing. The content of this video is from a paper from Gustavo Camps Valls. Here is the link where you can find the paper if you want to go deeper and read the entire content. And also here below you have my contact info if you want to make any comments about this video, right? So let's get started. Going ahead, remote sensing data processing, okay? Remote sensing data processing deals with real-life applications with great social values. What does that mean? Well, let's get some examples. For example, urban growth monitoring, estimating temperature, fire detection, flood prediction, and environment destruction, environment problems that we have nowadays. Okay, here are some examples. So, machine learning and signal processing play an important role in this game nowadays, right? So, why to monitor the surface? Well, by monitoring urban growth, estimating temperature or ocean salinity, and identifying objects on the surface, remote sensing provides valuable information for policy and decision makers, as well as for tourism or defense applications. Okay? But how is the principle of imaging spectroscopy? Okay, we can see here in the figure that we have a surface, and in this case the Earth's surface, and in this figure we have some different shapes, different images with different shapes and different colors. This is the representation of materials or objects in the surface. So materials in the surface reflect, absorb, and emit electromagnetic radiation at different way, depending of the molecular composition and shape, as we can see here in the figure. Different shapes, right? Different shapes. Remote acquisition exploits this physical property and deals with the acquisition of information about the sun. The acquisition is done by airborne or satellite spectrometer at different wavelengths. As we can see here in the figure, we have a satellite pointed to the surface. Also here in the figure, we have another graphic that shows the radiance of materials like soil, water, vegetation. So we have different radiance for different materials that can be, and this information can be acquired by the airborne or satellite spectrometer. Okay, so we have traditional machine learning applications for remote sensing. Why am I saying traditional, the word traditional? Because nowadays, actually, we already have some resources with new trends, the traditional applications for this field. Okay, let's see the examples. Image classification for classification maps, for example. We can see some subsections of this application, like, for example, supervised image classification for labeled information. Some methods used are neural networks, support vector machine. More applications, unsupervised image classification for unlabeled information. Some methods used, clustering, neural information, SDM. More applications, multi-temporal classification and change detections, usually for time series information. More applications. Feature selection and extraction. More applications. Signal unmixing for pixels, where pixels are mixing of signatures of various materials. In this case, we need applications for unmixing this information, okay? And regression and model inversion. Some methods used: neural network, support vector regression, relevance vector machine, Gaussian processes. Now, talking about new trends, machine learning application, we have some examples like manifold learning for dimensionality reduction, more applications, semi-supervised learning for exploit labeled data. We have also transfer learning, we have also active learning, and we have also structured learning. Okay, well, that's it for this video. That's it, what I would like to talk about for remote sensing. And if you, as I said, if you want to get more information, you can take a look in the link and see the entire paper. Okay, thank you for watching, and see you in the next video. Okay, bye bye.